Today we're going to have a look at expanding brackets containing algebraic terms. For example, how would we multiply out x plus a multiplied by x plus b? So whenever we're multiplying two numbers, for example 5 times 7, implicitly we're finding the area of a rectangle with dimensions 5 and 7. Obviously the area here is 35. So we can use a similar sort of intuition to see how we might approach the expansion of x plus a multiplied by x plus b. Namely by looking at a rectangle with dimensions x plus a and x plus b. Now we want to break this down into smaller rectangles of side lengths x and a and x and b individually. So let's write it like this. We'll have some length up is x, it's unknown obviously, and then the rest of it is a, so the length of that is just x plus a as before, and then we'll do a similar thing for x and b. Obviously your length there is x plus b. And now we're going to split this rectangle into 4 smaller rectangles, and we'll consider each area individually. So first let's look at this area here. So that's got side lengths x and x, it's a square, so the area is x times x, which is x squared. Now let's look at this area here. We can bring this x up here because it's the same thing, and the area is now a times x, which is just ax. Now let's look at this area. We can bring the b up here and the a here. The area is then clearly a times b. And then lastly, let's look at this area, number 4. You can bring the x here, and we can see the area is b times x, which is just bx. So the total area is then clearly just the sum of these 4. So that's equal to x squared plus ax plus ab plus bx. Now combining like terms, we get the final result, x squared plus a plus b multiplied by x, and then plus ab. So that's our general result here for expanding two general linear terms multiplied together. So let's take a look at some other questions to see how this might be applied to things with more terms. So first we'll just practice the equation above, but with set values of a and b, say x plus 4 and x plus 1 multiplied out. So we can see from above, but what we're really doing is we're taking the combination of each term multiplied together. So we could draw this as arrows pointing between each term. So here we have x joined to x, x to 1, and then 4 to x and 4 to 1. And we want to multiply them and add them up. So we consider that x times x first, we have x squared, and then the x times 1, which is x, and then the 4 times x, which is 4x, and then the 4 times 1, which is 4. And we can tidy up the terms to get 5x, like that. We see this is congruent with the expression that we had above. A plus b is 4 plus 1 is 5, and ab is 4 times 1, which should be 4, not 1, my mistake. So let's have a look at another question. This time we'll take one with 3 terms. Do x times 2x plus 3 times x minus 7. So because multiplication is associative, we can just consider any 2 pairs of these terms. So let's just multiply x into one of these terms here. So we'll do x times 2x and x times 3. And then that'll be one of our brackets, 2x squared plus 3x. And then obviously the x minus 7 is left unchanged. And then we can just apply the method before. So we'll do 2x squared times x, which is 2x cubed. Then we can do 2x squared times minus 7, which is minus 14x squared. And we can do 3x times x, which is plus 3x squared. And we can do 3x times minus 7, which is minus 21x. Now we have common x squared terms, so we can simplify. Minus 14 plus 3 is minus 11, so we get minus 11x squared. And that right there is the final result. Okay, one more question before the challenge. Let's just do an expansion containing 3 terms, like so. So like I said before, we can consider any two pairs, or any pair of these terms individually and expand them, and then consider that as an individual bracket that we're then multiplying out. So let's just take this pair here to begin with. So let's do 2x times 3x is 6x squared, and 2x times minus y is minus 2xy. 5y times 3x is plus 15xy. 5y times minus y is minus 5y squared. And then we're multiplying that, obviously, by this remainder term here. So we can combine these two here to get slightly more simple 6x squared plus 13xy minus 5y squared times 2x plus y, and obviously these are equal. Now, we have a slightly more complicated expression here, but the same rules apply. If this was a rectangle, we'd split it into the 6x squared, the 13xy, and the minus 5y squared. Obviously this is minus, so it's kind of strange to think of it as a length, but the method still works. And then we just have the 2x and the y, and we're multiplying out all combinations of terms to get the area of the total rectangle. So if we do that, we get, I'll draw the arrows, 6x squared times 2x is 12x cubed. 6x squared times y is plus 6x squared y. And then we can do this combination, which is 26x squared, apologies, 26x squared y, and 13x y squared, and then the last two terms we have minus 5y squared times 2x, which is minus 10y squared x, and then we have minus 5y squared times y, which is minus 5y cubed. We can combine these two terms and these two terms, and we'll end up with the final result, which is 12x cubed plus 32x squared y, 13 minus 10 plus 3x y squared minus 5y cubed, and that should be our final result. So the challenge question for this video is x plus y to the power of 4. So this effectively has 4 terms in the expansion, but we can somewhat reduce the amount of computation we have to do because it is the same term in the expansion. So we can write this as x plus y squared, but then squared again. So this way we only need to expand out brackets 2 times. Obviously slightly larger brackets, but that's okay. We just apply the same method as before. So what is x plus y all squared? That is x squared, and then you get the x times y and the y times x, so that's 2xy altogether, and then y squared. And we want to square this. So a way to do this, or a way to see it a bit easier, is to write out the 2 terms that we want to expand instead of just writing the squared, because then it's more visual and you can see what you're doing. And then, yeah, we just want to take combinations of all these terms. So let's start with x squared times x squared, which is x to the 4. We'll do x squared times 2xy, which is 2x cubed y. Then x squared times y squared, which is just x squared y squared. Move on to the next term. Now we have 2xy times x squared, which is plus 2x cubed y. Then we have 2xy times 2xy, 2xy all squared, which is 4x squared y squared. Then we have y squared times 2xy, which is plus 2xy cubed. Last term, we have y squared times x squared. Then we have y squared times 2xy, which is plus 2xy cubed. And then lastly, we have plus y to the power of 4. So obviously we can do some combining of terms here. So let's consider xy cubed terms. So one there, there's one there, and I believe that's all of them. So that'll be, let's just start writing the terms. We have 4xy cubed, so that's that one done, and then those two. Let's consider the yx cubed terms, these two here. That'll give us 4x cubed y, and then the x squared y squared terms, which altogether gives us 1 plus 4 plus 1, which is 6x squared y. And then lastly, apologies, this is the last term, y to the power 4. So we can write this in a slightly different way, in terms of decreasing powers of x, like this. There's 4x cubed y, and then the y to the power 4 in the end, that's obviously x to the power 0. Apologies, this term is not right. It should be x y cubed. There we go. So coefficients here are 1, 4, 6, 4, 1. So it's like a mirror. Now this is a result of Pascal's triangle, and we'll see this result but more generalized to higher powers when we come to meet the binomial expansion. So yeah, that's the solution to this question. If you have any queries or questions or any feedback on the video, then please let me know in the comments, and don't forget to like and subscribe.